Lesson 15. Solving trigonometric equations with multiple trigonometric functions. In this section, we're going to be talking about the strategies that one may use when trying to solve equations with multiple trigonometric functions. By that, I mean that you're going to see equations that involve multiple expressions of sine, cosine, and the other trigonometric functions, and our goal is still going to be to try to solve for the variable that happens to be inside of one of the trigonometric functions. These can get a little bit complex, however, these strategies can help you when trying to approach some of these problems. The first one that I would recommend here, the best thing to keep in mind overall, is to never divide both sides of an equation by a trigonometric function, as you will often lose solutions this way. This can be demonstrated in an algebra context if you consider an equation such as 2x equals x squared. If my goal here is to try to solve for x, some individuals may look at this and say, well, because I have x on both sides of the equation, why not simply divide both sides of that equation by x? That would give you 2 equals x. Awesome, we found a solution. But that's the thing, we found a solution. When we divided by x, we technically lost a solution to this problem, because there is another value that I can plug into that, 2x equals x squared, in order to have that equality hold. The way we can find that is, instead of dividing by x, if you're ever tempted to divide by a function in these cases, try instead to maybe add or subtract it to the other side of the equation. For example, I can rewrite this as 0 equals x squared minus 2x. With everything there on the right side, I see that value of x in both terms, and instead of dividing it, what I could do instead is factor it out of both terms to give me 0 equals x times the quantity x minus 2. And when I have two terms multiplied to equal 0, well, that can only happen if one of them equals 0. If, perchance, if x equals 0, or if x minus 2 equals 0. If either of those equals 0, then this equality holds true. Well, that second case, x minus 2 equals 0, that's where our solution from before came from, x equals 2. However, we now have another one. We also now have x equals 0 as a possibility. When we divided by x earlier, that would have lost that solution. So be very careful. If you're ever tempted to divide both sides, I would recommend instead try moving it using a different operation, typically addition or subtraction. Next, we have to try and change every trigonometric function in the equation to the same trigonometric function. You can use Pythagorean, double angle, sum and difference, and half angle identities for this purpose. There are other identities you may use, but those are the most common ones. If you do still have multiple trigonometric arguments to various powers, you can then try to use substitution to try to make the equation look more like a polynomial. This is going to be one of the most common strategies that you will see in the examples throughout Lesson 15. When you have multiple trig functions like sine and cosine floating around in an equation, try to use an identity to change one of those into an expression involving the other. For example, if I see sine squared of x somewhere in an equation, I should know that I can change that into a few things. For example, I could try to use the Pythagorean identity that would allow me to change sine squared into the expression 1 minus cosine squared of x. That can help if I see other terms in the equation involving cosine. So it's one of the main things to look out for. If you see multiple trig functions, try to change it all into the same type of trigonometric function. As denoted from that sub-bullet, if you do happen to see trigonometric arguments to various powers, substitution can help to at least make the equation look visually a little bit simpler. For example, if I see sine squared of x plus 4 sine of x plus 4 equals 0. This can appear complex to some individuals. So let's say I call sine of x another variable just for substitution purposes, just to make it look a little bit easier, and that might let me know what else I can do with this. For example, maybe I'll call sine of x the variable a. I like the variable a. That means I would rewrite this equation now as a squared plus 4a plus 4 equals 0. That now looks like a polynomial, and I might be able to manipulate that in order to get a by itself using multiple factored terms. So, substitution can help to at least clean up the equation. Just remember that when you are done and you do have your replaced variable by itself, to go back and put sine of x, in this case, back into your solution. Remember, our overall goal is always to solve for the variable originally. So in this case, I would be solving for x is my main goal, not a. That can just help me get there. Next, if you cannot use an identity to change all functions to the same trigonometric function, that normally is going to happen when you have multiple terms interacting with each other and you can't separate them in a way. I would recommend to try to get all functions to one side and factor a common term. So if you see multiple terms and maybe one of them has a sine in it, the other one has a sine in it, but there's also a tangent in one of those terms. If you see a common term in both of them, try to get them to the same side of the equation and factor, like I demonstrated earlier. That can help for a couple cases as well. The last one, and I want to highlight to make sure that this is clear that this is the last thing that I would recommend doing after you've tried the other methods. You can try to change every function into sine and cosine functions using quotient and reciprocal identities. This is always an option, but I recommend that it should be saved for last, as usually when you do this, it tends to not be immediately obvious what you should do to move forward. Instead, there is typically an easier identity that you can apply to solve most of the problems that you will see throughout Lesson 15. However, this is something you can always keep in your back pocket as a good default to go back to.